Okay, page 6, number 5. So for this video, we're going to be doing everything using the algebra method. So if you want to look at the non-algebra method, please go see the other video. This is non-algebra method. Okay. Find the constant term in the expansion of this. Okay, remember when we use the algebra method, we're just going to fill in the famous general term formula, which we can copy out of the formula booklet. Okay, so this is A, this is B, and this is N. Okay, and I did a good job of like not, covering everything up so you can't see what it says. So I'll do that. Okay, so N is 9. R we don't know yet. A is X. N minus R would be 9 minus R. We don't know what R is, so we just leave 9 minus R. And B is this mess, negative 3 over X squared to the R. Okay, so all we did was fill in N, A, N, and B. And then we say, okay, we want the constant term. Now, the constant term doesn't have an X in it, but in order to make it easier to do the algebra, let's say that we got a bunch of numbers, we got a coefficient, and then we have X to the 0, which is basically saying the constant term. X to the 0 is 1, right? So X to the 0 is like not having an X term, okay? By doing this, it's easier to understand the rest of it, which is, okay, now I'm going to take the yellow parts, which are the variable contribution, and I'm going to write it out, just the variable parts. And instead of X squared, I'm going to put X to the negative 2, because that makes it a little bit easier to put the thing in the numerator. Do you notice I just eliminated the coefficient? We don't know what the coefficient is anyway, so it's not helpful. But we're just talking about the yellow part, which is the variable part. And this part of the right side is the variable part. So we're just going to look at the X to the 0. Now we're going to combine these exponents. This is negative 2R, 9 minus R, and we're going to add it to this. So it'd be 9 minus R minus 2R is 9 minus 3R. And again, if you don't like this algebra, go watch the other video, the non-algebra method. Okay, now 9 minus 3R equals 0, right? So we know that R is equal to 3. Okay, so we know that R equals 3. R should always end up being an integer. If you didn't end up with an integer, you did some wrong math. Okay, or the problem is impossible. Now what we're going to do is we're going to actually figure out what the coefficient is. We're going to do that by, now that we know R, we're just going to put R back into the general term formula. That was the only thing we didn't know, right? 9 minus R is 6. Negative 3 over X to the R. Okay. Let's use the calculator to figure out what 9 chooses 3 is. 9 chooses 3. 84. Okay. So this will be 84 X to the 6th times negative 3 to the 3rd, which would be negative 27. And the X cubed in the bottom, we'll just put it here. So now we know, oh, sorry. This is X squared here. So X squared to the 3rd is X. Do you notice I like panicked because like the bottom needs to cancel out with the top in order to be a constant term? And I was like, what? Why doesn't it cancel out? Because I copied it wrong. B is equal to X to the negative 3 over X squared. I need to put the X squared there. Okay, so now the X to the 6 cancels out, and I'm left just with 84 times negative 27. 84 times negative 27 is negative 2268. So my constant term is negative 2268. And I'm done. All right? All right. Let's do the next one. X plus 2 over X squared to the 15th. We are going to once again use the algebra method. Again, if you don't like this algebra method, no problem. Go watch the other video. Here, let's identify our A, B, and N. A is X. B is 2 over X squared. No negative sign this time. A little bit easier. N equals 15. And we're looking again for the constant term. Remember, the constant term is the X to the 0 term. So let's fill our N and A and B in, and we're going to leave our R unknown. B is 2 over X squared to the R, and then we're going to set that equal to blah, 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 that's the coefficient, to the X to the 0. And then we're going to identify all the variable parts. So this is the variable, this is a variable, and this is a variable. And then we're just going to write out the variable part because the variable part is equal to each other. So X to the 15 minus R, X to the negative 2 to the R equals X to the 0. And then let's combine these two exponential expressions into one with one base. 15 minus R plus 2R. 15 minus R plus 2R. I'm sorry, minus 2R. Minus 2R. Minus 2R. Why do I keep saying plus? Right? Negative 2 times R is negative 2R. Okay, and we're going to add them together. So that would be X 15 minus 3R equals X to the 0. And you can already see that the R is probably 5. Let's just make sure. 15 minus 3R equals 0. Yes, R is equal to 5, right? Okay, now that we know the R equals 5, all we need to do for the last step is put R back in to the general term formula that's partially filled in. Oops, what happened here? Okay, oh, actually I filled in. Let me fix this. This used to be 15. Okay, now let's fill it in. So it's 15 chooses 5, X to the 15 minus 5, 2 over X squared to the 5. Okay, and now 15 chooses 5 is 15 chooses 5, 3003. So it would be 3003 X to the 10th, and then times 2 to the 5th. 2 to the 5th is 32. If you did 2 to the 5th on the calculator, it would say 32. X squared to the 5th in the bottom, it gives me X to the 10th also, so those two cancel out. So my coefficient is going to be, actually it's not really a coefficient, it's a constant term. For a constant term, we don't say coefficient. We just say constant term. 96096. 96096. Okay, 3003 times 32. Good. And X to the 10th over X to the 10th cancels out. Okay, that's the algebra method. How do you like that? Okay, let's do number 7A. Find the coefficient of X to the 5th in the expansion of this here. Whoa. So when we did a problem like this in the past, we did a complete expansion of this to make it easier, right? And then we use lattice multiplication with the binomial. This time, in principle, we still want to do a complete expansion, okay? But as we do it, we'll see that you don't really need to develop the whole thing, okay? So I'm going to go ahead and do it here instead of on the template. You guys are pretty used to following the format, right? So I'm not going to put the Pascal's triangle coefficients. I'm just going to put the 8 chooses 0, 8 chooses 1, 8 chooses 2, and so on, okay? Okay, and then it goes to 8 chooses 6, 8 chooses 7, and A chooses 8, and that's the end. All right. And we're only going to need a couple of these, and we're going to see which ones they are in a second, okay? These are the triangle terms, or the triangle expressions. Let's put the circle expressions. It would be x squared, x squared, x squared, x squared, etc. And then the x squared is taken to the power of the 8th, 7th, 6th, 5, 4, 3, 2, 1, 0. Okay. And then the square term would be the 1, and it would be 1 to the 0, 1 to the 1, 1 to the 2, 1 to the 3. Oh, but 1 to the 0 is 1, 1 to the 1 is 1. So that doesn't affect it. So we're kind of done. We don't need to put the b term, right? So here's the whole thing, all right? Now we're going to see how we can be a little bit smart about this. Okay, so now what we want to do is we want to take this expression. Now we're going to multiply it times the binomial using lattice multiplication. But let's see, I'm going to put the x plus 2 here. Okay, but I don't need to make the thing 9 terms wide, because I know that some of these have no chance of working, right? Basically, I want everything that contributes to be the x to the 5th term, okay? But like some of these are way too big, right? For example, the x2 times 8 is 16. X to the 16th, x to the 14th, x to the 12th. These are too big. They're never going to be x to the 5th, right? 10th, 8th, 6th. These are too big. Oh, now we're getting somewhere. So this is the 4th, this is the 2nd, and this is the 0th. Okay, so this one has a chance of working. This one has a chance of working. X to the 6th is already too big, right? Because if I multiply x times x to the 6th times either of these, it's not x to the 6th anymore, right? So the only ones I'm going to write down are like, these two, I guess. All right, so I only need to write down these two. So I'm going to have 8 chooses 6, x to the 4th. And I'm going to have 8 chooses 7, x squared. And I don't think I even need this one, because if I have a constant term and I multiply it times these, I'm not getting x to the 5th either. Okay, so let me now multiply. So if I'm going to multiply this times this, I would get 8 chooses 6. X to the 4th times x, which would be x to the 5th. That looks good, doesn't it? If I multiply this times this, I would get 8 chooses 6, x to the 4th, and times 2, right? Okay, and then this times this would be 8 chooses 7, x to the 3rd. And then this times this would be 8 chooses 7 times 2, x squared. Okay, so we want to know the x to the 5th term. Most of these are not x to the 5th. This is to the 3rd, this is the 2nd, this is to the 4th. This is the only one that is x to the 5th, right? And we know that any of the other bigger powers, like this one here, x to the 6th, that wouldn't have been x to the 5th either, because if you multiply it times x and 2, it'll just be x to the 6th, x to the 7th, right? So we're left with only this. This is our only term. So now, just by thinking a little bit, we've eliminated everything that's higher order than this. So like everything that's up here, we eliminated because there's too high order. The exponents are too high. And then we just put everything below and we multiplied it out, and we saw that there was only one of 4 terms that actually works. So we just need to do 8 chooses 6. So let's do that. Oh, and yeah, 8 chooses 6. 8 chooses 6. So it would be 8 math chooses 6. And it'd be 28. So our answer is 28. The coefficient is 28. All right? Now, if you don't see that, you could write out the whole thing here. Make the thing, 8 terms or 9 terms wide, right? Don't expand it out. Just write 8 chooses 6, 8 chooses 7, etc. And then when you do that, you'll be able to see that, oh yeah, like, the x, this would be x to the 5th. It's the only one that's going to be x to the 5th, and that's what we want, right? Another thing about this grid that we just made, do you notice that when I do the diagonals, they don't have like terms? X to the 3rd, x to the 4th, it doesn't line up. Last time when we lined it up, these had the same degree. But it doesn't happen because, like, see, I don't have descending degrees here by 1. I have 2 steps here. So that's why it doesn't work out. Still, it's a useful way of organizing. Maybe you can't do the combined by like terms just by doing simple diagonals, but you could create some other patterns. Okay, so that was that one. Kind of challenging.